Okay, a particle in a uniform circular motion requires a net force acting in what direction? Okay, so again, just to rationalize through this, I'm going to attempt at drawing a rudimentary circle here, and we're going to pretend that it's a perfect circle. So there's our R line, there's one of our velocities, which is tangent to this R. And I'm just going to draw another one and draw another one. And each of these we're going to pretend is tangent to this R. Okay. So we have that V is R omega, and so A, our acceleration, so this is our velocity perpendicular to the R. So our acceleration perpendicular is dv by dt, which is R d omega by dt. And so if we're in uniform circular motion, then our omega is constant, so this will be 0. So that means that if our acceleration perpendicular is 0, that means that our force perpendicular is 0. Right, as F equals ma. So if the force perpendicular is 0, that just means the force can't possibly act in any direction perpendicular. So it has to act, the force must be parallel to R. So in these cases I'm talking about perpendicular and parallel to our R vector. Okay? So the force is never acting perpendicular to R, it's actually acting parallel to R. And if we look at our velocity vectors, so this is without any real math, but if we look at our velocity vectors, they're moving inwards towards the circle each time, right? They're not going outwards, they're going inwards. So that means that our force, which is parallel to R, must act in along R towards the center. And so it's often called a centripetal force or a center-seeking force. Now let's look at the solution here. So an object in a circular motion, and I'll just put towards center, just to drive it home. An object in a circular motion is kept by a force called centripetal force. Centripetal force always acts perpendicular to the motion of the object. Yeah, so perpendicular to the motion is perpendicular to R. So it always acts parallel to R, which is towards the center of the circular orbit. Satellites have, yeah, okay. So solution is correct. Looks good.